All right, so graphing quadratics in standard form. So again, the notes are printed off because of the graphs. You don't have to use them if you don't want to, but I would recommend it. I think it will make your life a lot easier. I don't think I've used the blue marker this year, so we'll see how this one works out. All right, so the parent function that we talked about with linear was y equals x. Does everybody remember that?
Yep.
Now, for this, it is just y equals x squared, which is essentially the same thing as y equals x, but now we have the x squared, and that's what makes it a quadratic. So what that basically means is whatever value we put in here, we're going to have to square it, and that's going to produce our y value. I'm going to grab my answer key just so I don't make any mistakes and confuse and make your life more difficult. All right, so I'm going to start off with -3 here. And if I square -3, what do I get?
9.
Positive 9, right? Because -3 times -3 is a positive 9. Now what that means is that I can graph -3, 9 on this parabola. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is a point on the parent function. Your next point is going to be -2. What is -2 squared? 4. So another point I'm going to have is -2. So -1, -2. 1, 2, 3, 4. Then we're going to have -1. What is -1 squared? Positive 1. So we're going to have -1, 1. And then finally, the actual vertex or the center part of this is going to be when I put 0 in. Because what is 0 squared?
0.
And therefore, I go through the origin. Now let's just stop for a second and rethink about this. If I go through the origin, does it mean that I am proportional?
No. Well, yes.
Yeah, it does, because I don't have a y-intercept. Is this paper? Sure. Yep. Madison, I just got a call. I want you to go to the office with your things. Don't have any more details. They just called. So hopefully you're just getting an early dismissal. You have an orthodontist appointment you didn't know about. But yep, nope, you do. I believe that you do. They're going to give you some braces and call it a day. It's recording, Addison, so I will get it uploaded, okay? All right, so as we continue through this, I'm just going to work my way back. So I'm going to do 1 in my x value again. We're going to square 1, which is going to give me 1, 1. That puts me right here. Then we're going to have 2. 2 squared is 4. So it's going to be 1, 2, 1, 2, 3, 4. And then finally, we're going to go with the 3 and the 9, which is going to be right here, Madison. Okay? Yeah, what's up? For the -2 right here, how do I get positive? Because if I'm squaring a number, what that really means is -2 times -2, and the negative times the negative becomes a positive.
So if it's just positive, it's just positive.
Uh-huh, because you're just squaring that number. So we had created a parabola here. And so the reason I wanted to spend time creating that parabola is because I wanted to show you how we actually get the points of this. They're not just random like circles, like they actually do have meaningful points. And whenever we plug into an equation, just like in our slope-intercept form, it is going to produce stuff on the actual table. Does that make sense? All right. So for this, we know that our parabola is the actual shape of the line. The axis of symmetry, just to give you guys some more vocabulary, is the vertical line that divides the parabola, the vertical line that divides the parabola. So it's the one that goes right through the middle. Then finally, the vertex is going to be either the highest or lowest point. We all good there? Yeah, what's up, Katie?
What was the parabola?
Parabola is just the shape of that line. So you can just put the U-shaped line if you wanted. I wasn't going to put a definition, the description of the line. Sorry, I was gonna drink real quick. You okay right there?
Me?
Yeah.
Yeah, it's just breathing. Okay, that's totally breathing.
All right, back at it. Everybody good with this first part? Good with the parent function being y equals x squared because it goes to the origin 0, 0. Good with how I got my table and how I figured out the points on the actual line. All right, cool. I guess the last thing I want to mention about that is obviously if I were to find numbers in between here, like let's say I took 0.5 and then I were to square 0.5, it's going to have a number on the line still. We're all okay with that, right? These are just the numbers that I chose to give you. All right, we'll go ahead and go to the next page. All right. Okay, so for this next part, we're on question 3 now. It says solve for that part. It says solve for that following quadratic equation. Now, we're in a good spot here. We learned yesterday that the standard form is ax squared plus bx plus c. That was the one that we discussed the most. And if I take a look at what's given to me on this board here, it's not quite in that form yet. I have ax plus c equals b. How can I get this over to the other side? Subtract it, right? I'm going to subtract 4x from both sides. And now I'm left with x squared, minus 4x plus 7. Are we all okay with that? Now let's think about a couple different things here. We know that because my a is positive, what does that mean? It's going to open up. If a is positive, that means that we have a minimum and my parabola opens up. Can everybody see that? My a is 1, and so therefore it's a positive value. My b is negative 4x. We're not quite to that point yet. And finally, we have a c value of 7. Whatever your c value is, that is where you're going to cross the y-intercept. It doesn't mean it's where our vertex is. It just means that's where we're going to cross the y-intercept. Understood? So what I can do is by looking at this problem, I know 1, 2, 3, 4, 5, 6, 7. This has to be a point on the graph. Didn't say it was the vertex. Just said that has to be a point on the graph. Everybody okay with that part? Now what we need to do is we need to figure out where my vertex or where my axis of symmetry is going to be. Now that formula can be found on our star chart. Axis of symmetry. And here's what that is. X equals negative b over 2a. X equals negative b over 2a. X equals negative b over 2a. So if I wanted to solve for this, I'm going to leave my x here. I'm going to leave my negative. What is my b term, though? Negative 4. Now, again, this is important. Notice that there's a negative in the problem, and notice that my b is also negative. So I can't just get rid of that one. It's going to be negative 4. We'll explain that in just a second. We've seen stuff like that already in this class. I just want to make sure you're aware of it. Now it's going to be over 2. And what's my a value? It's just 1, right? X is not an unknown number. I don't know what x is. But the value in front of that x is 1. Okay, so let me reiterate how I got this information. Here's my formula. X, which is the axis of symmetry, is equal to negative b divided by 2a. I kept my negative. My b was negative 4, so I have negative 4 divided by 2 in the equation, and a, which is equal to 1. We're all okay with that? All right, now if we just solve it out, well, negative 1 times negative 4 gives me a positive 4. 2 times 1 gives me a 2, which simplifies down to 2. So here's what this means. My axis of symmetry, my invisible line, is going to cross at 2. So here's 1, here's 2. So I don't know where the actual parabola is at this time, but I know that my axis of symmetry is going to cut through at 2. So again, I don't know if this is the correct one, but that means that somehow like my parabola could look like this, or it could look like this, or it could look like this. I don't know yet. We haven't gotten that far. But what I'm telling you though is that my axis of symmetry where I'm cutting the parabola in half is going to be at the 2 point. Are we all good there? Questions, concerns, ideas, thoughts? We're all good? All good? All right. Again, we know it opens up because my A value is positive. We use this formula found on your star chart called the axis of symmetry to figure out where that invisible line goes. Cool? All right, on this next one. This one's already in your format here. We're already good there. Okay? So here's what I want to do. It says find the zeros. First thing we're going to do is we're going to find the axis of symmetry first. Which again, the formula is going to be x is equal to negative b over 2a. I want you to go ahead and try to find the axis of symmetry for me. Go ahead and try to find the axis of symmetry for me. Once you think you've set it up, let me know, and I'll check it before we just start solving for it. Hayden, what do you think?
2.
You think the axis of symmetry is 2? Okay. Can anybody help me set it up so that we can see what it looks like to get it to be 2? Steven, what would you do?
So it was x equals negative 8
Good.
over 2 times 2.
Very good. Does everybody see how Steven did that? Anybody not understand that? Need me to repeat it or go over it again? Katie?
How was it 2 times 2?
Because you have a 2 in the problem, and then your a value, which is your first term, in front of the x squared is also 2, so that's why it's 2 times 2. Okay? Well, negative 1 times negative 8 is going to give me 8. 2 times 2 is 4. So just like Hayden said, x equals 2. So what that means is that my vertical line, my axis of symmetry, is going to go right through here. Is everybody okay with that? Let's see who's trying to join us. Okay? All right. I'm going to try to jump a little bit here. I'm going to try to tie some extra pieces in. Is this parabola going to open up or down? It's going to open up because my a value is. I also know that I'm going to have an intersection on the y at what point?
6.
6, because the last term, this is my b basically, not my b, but like my y-intercept. We're going to have 1, 2, 3, 4, 5, 6. Okay, now, again, we're just kind of brainstorming here. This is early on. We know that my parabola has to make the exact same trajectory the entire way through. Is that correct? So if I have one at this point, don't I also have one right here? Because it has to be symmetrical, cut right down the middle. Has to cut it right down the middle. I'm going to stop this video and keep going, but I